Look up at the night sky for a moment. It seems peaceful, doesn't it? Static, silent, and eternal. But out there in the dark, a cosmic car crash of unfathomable proportions is already in motion. Right now, as you are listening to these words, our home galaxy, the Milky Way, is screaming through the void at 400,000 kilometers per hour toward our neighbor, the Andromeda Galaxy. They are on a collision course that will eventually rewrite the map of our local universe. But what if that collision happened exactly now? What if the orbits shifted, the distance vanished, and these two titans of the cosmos slammed into each other this very second? Would the stars crash into each other like billiard balls? Would Earth be flung into the freezing abyss of intergalactic space, or would we even notice anything at all? Today, we are breaking down the physics of a galactic merger to see what happens when billions of stars, massive black holes, and trillions of tons of cosmic dust dance a violent tango. We are going beyond the CGI animations to look at the terrifying reality of tidal tails, starburst knots, and the eventual birth of a new, unrecognizable mega-galaxy. Stick around, because the truth of a galactic collision is far stranger and much slower than you have ever been told, and the fate of our solar system is hanging in a very delicate balance. To understand a galactic collision, we first have to grasp the sheer scale of the objects involved. A galaxy isn't a solid object. It isn't a spinning frisbee of rock and metal. It is mostly empty space. If the sun were the size of a ping-pong ball in New York, the nearest star, Proxima Centauri, would be another ping-pong ball located in Chicago. That is a lot of room for activities. This is why, when two galaxies collide, the individual stars almost never actually hit each other. The odds of two specific stars colliding are so low that they are practically zero. It's like two swarms of gnats flying through each other. They might pass through the same volume of air, but the gnats themselves never touch. So, if the stars don't hit, why do we call it a collision? Because while the stars are small and lonely, the gravity they exert is massive. The moment the outer halos of the Milky Way and Andromeda begin to overlap, the real show starts. Gravity begins to stretch and pull at the edges of both galaxies. Astronomers call this tidal interaction. Imagine a giant hand grabbing the beautiful spiral arms of our galaxy and pulling them like taffy. Long streams of stars, gas, and dust are ripped away and flung millions of light years into space. These are called tidal tails. From the perspective of an observer on Earth, the night sky would transform over millions of years. The familiar band of the Milky Way would become distorted. A second, glowing path of light would appear in the sky as Andromeda draws closer, eventually becoming larger and brighter than any moon. But let's talk about the gaseous medium. While stars are like tiny specks, the gas clouds in a galaxy are enormous. When these clouds from two different galaxies slam into each other, they don't just pass through, they compress. This compression triggers a phenomenon called a starburst. Gravity causes these compressed clouds to collapse rapidly, giving birth to millions of new stars all at once. The galaxy would light up with brilliant blue clusters of massive, hot stars. It would be a cosmic baby boom. However, this comes with a price. These massive newborn stars burn through their fuel incredibly fast and end their lives in spectacular explosions. This would flood the merging galaxies with radiation and heavy elements. If you were standing on a planet in the middle of a starburst region, the sky would be filled with glowing nebulae and frequent, blinding flashes of light. As the two galaxies continue their dance, they pass through each other and then, thanks to gravity, they are pulled back for a second pass. It is a slow-motion oscillation that takes billions of years to settle. During these passes, the orbits of the existing stars are completely haywire. Our own sun might be displaced. There is a statistically significant chance that the sun could be tossed out into the outer reaches of the newly forming galaxy, or in a more dramatic scenario, ejected from the galaxy entirely. If that happened, we would become a rogue solar system, drifting in the lightless void between galaxies. We wouldn't lose our sun or our planets. Now, let's talk about the centers of these galaxies. At the heart of the Milky Way is Sagittarius A star, a supermassive black hole with the mass of 4 million suns. Andromeda has its own monster, which is even larger, perhaps 30 or even 100 million times the mass of our sun. As the galaxies merge, these two titans will eventually find each other. They will begin to orbit one another in a gravitational death spiral. As they get closer, they will stir up the gas and dust in the galactic center, creating a frenzy of activity. This can turn the black holes into quasars. A quasar is one of the brightest objects in the universe, powered by the incredible heat and energy of matter falling into a black hole. The center of our new merged galaxy would glow with a light so intense it could potentially strip away the atmospheres of nearby planets. Eventually, the two black holes will merge into one even more massive singularity. This event would send out gravitational waves so powerful they would ripple through the entire fabric of space-time. To any civilization watching from millions of light years away, the Milky Way would appear to suddenly flare up and then slowly change shape. We would no longer be a spiral galaxy with beautiful arms. We would become an elliptical galaxy, a giant, featureless swarm of aging stars. Astronomers have already given this future home a name, Milkomeda. It sounds like a brand of breakfast cereal, but it represents the final, stable state of our combined galactic neighborhood. But what if this happened right now? If the collision started this afternoon, you wouldn't feel a thing. You wouldn't hear a sound, because sound doesn't travel in a vacuum. You wouldn't see a massive explosion. Instead, the changes would be glacial. To us, it would look like the stars were just slowly drifting into new constellations. Our grandchildren would grow up under a different sky, and their grandchildren would see a massive, glowing nebula where Andromeda used to be. The danger to Earth wouldn't be from a direct hit, but from the changing environment. As we move through different parts of the merging galaxies, we might pass through regions of high radiation or areas with a higher density of stars, increasing the risk of a nearby stellar explosion affecting our atmosphere. One of the big secrets of the universe is that galactic collisions are actually how the universe grows. We see examples of this everywhere we look. The Antennae Galaxies are a famous pair currently in the middle of a violent merger, looking like two tangled insects in space. The Mice Galaxies are another pair, showing off beautiful long tidal tails. These aren't cosmic accidents, they are the fundamental building blocks of galactic evolution. The Milky Way itself has a history of cannibalism. We have found scars in our galaxy's halo that prove we have swallowed smaller satellite galaxies in the past. We are a product of previous collisions. Andromeda is just the first time we are meeting someone our own size. Some people worry that a galactic collision would mean the end of life on Earth. But the reality is that life is far more likely to be affected by the aging of our own sun than by the merger with Andromeda. By the time the two galaxies truly become one, about 4 to 5 billion years from now, our sun will already be expanding into a red giant, making Earth uninhabitable. The collision might actually provide a second chance for life elsewhere. All those new stars being born in the starburst regions could have their own planets. The merger reshuffles the deck, creating new opportunities for solar systems to form in ways they never could have in a quiet, stable spiral. The physics of these collisions is studied using massive supercomputer simulations. Researchers input the number of stars, the amount of dark matter, and the velocity of the galaxies, and then they hit play. What they see is a chaotic, beautiful mess. Dark matter plays a huge role here. Even though we can't see it, dark matter makes up the bulk of a galaxy's mass. It acts like a gravitational glue that keeps the galaxies from just flying past each other. The dark matter halos are the first things to touch, and they create the initial drag that slows the galaxies down, ensuring that they will eventually fall into each other's embrace. Without dark matter, galactic collisions would be rare near misses, instead of the mergers we see today. Imagine the view from a planet located in one of those tidal tails. You would be millions of light years away from the main body of the galaxy. Your sky would be mostly black, with a distant glowing smear representing the merging wreckage of your former home. It would be a lonely existence, but perhaps a peaceful one. Far away from the chaotic radiation and crowded star clusters of the center, you would be a true pioneer of the intergalactic void. On the other hand, if you were in the center, the night would never truly come. The sky would be filled with so many stars and glowing gas clouds that it might never get darker than twilight. This brings up an interesting point about the zone of avoidance mentioned in other astronomical contexts. During a merger, our view of the rest of the universe would be constantly changing. As the dust clouds shift and compress, new windows into the deep universe would open, while others would close. Future astronomers in Milkomeda might have a much clearer view of the distant cosmos, or they might be perpetually shrouded in the remnants of the merger. It all depends on where their solar system ends up in the new elliptical structure. The concept of a collision also forces us to rethink what a galaxy actually is. Is it the stars? Is it the gas? Or is it the gravitational field? During a merger, these components can be stripped away and separated. We have seen ghost galaxies made of almost entirely dark matter and star-only clusters that have been ripped out of their parent galaxies. A collision is a laboratory of extreme physics where the normal rules of galactic structure are thrown out the window. It is the ultimate test of our understanding of gravity and fluid dynamics on a cosmic scale. What about the impact on our neighboring galaxies? The Milky Way and Andromeda are the two big players in what we call the local group, but there are dozens of smaller dwarf galaxies, like the Magellanic Clouds, that orbit us. When the two giants collide, these smaller galaxies will be caught in the crossfire, and some will be swallowed up, while others might be slingshotted away like pebbles hitting a spinning wheel. The entire local group will eventually coalesce into one giant system. We are witnessing the very beginning of the formation of a massive galactic empire, governed only by the laws of physics. Scientists are also looking at how these mergers affect the habitability of a galaxy. Some believe that elliptical galaxies, the end product of mergers, are less hospitable to life because they have less gas to form new stars and are often filled with older, radiation-emitting stars. Spiral galaxies like our own are seen as the sweet spot for life. That means we are currently living in the golden age of the Milky Way. We are in a stable, star-forming environment. The collision with Andromeda will eventually turn our home into a retired galaxy where the fires of star formation have mostly gone out. It's a somber thought, but it's the natural life cycle of the universe. There is also the mystery of the Great Attractor and how it influences these collisions. While the Milky Way and Andromeda are headed toward each other, both are also being pulled toward a much larger mass in the distance. This means our local collision is just a small part of a much larger movement. We are like two passengers on a train who are walking toward each other while the train itself is hurtling toward a distant station. The scale of the movement is mind-boggling, and it reminds us how interconnected everything in the universe really is. If you could compress the 5 billion-year process of the Milky Way-Andromeda collision into a 1-minute video, it would look like a beautiful glowing dance. Two spirals approach, stretch out long arms to touch each other, zip through, spin around, and then slowly melt into a single glowing orb. It's a process of destruction, yes, but also of profound creation. It is how the universe recycles its materials, taking old, gas-rich spirals and turning them into massive, stable ellipticals. It is the ultimate recycling program. But let's focus back on the right now part. If this happened today, the most immediate effect would be scientific. Astronomers would be incredibly excited. We would have a front-row seat to the most significant event in the history of our galaxy. New telescopes like the James Webb would be pointed at the incoming clouds of Andromeda to study the first signs of interaction. Every piece of data would be a treasure. We would learn more about dark matter and star formation in a decade than we have in the last century. It would be the most unified period in human history, as the entire planet looks up at a sky that is visibly changing. The fear of a collision often comes from our human experience. On Earth, a collision is a car crash or a falling vase. It's fast, loud, and fatal. But the universe doesn't work on human timescales. A sudden galactic collision still takes millions of years to show even the slightest change. This disconnect between our lives and cosmic time is one of the most difficult things to wrap our heads around. We want the drama, the explosion, the day after tomorrow scenario. But the universe is patient. It takes its time. The collision is happening, but it is happening with a majesty and a slowness that defies our instincts. One thing that would definitely change is astrology. Now, science doesn't put much stock in horoscopes, but for thousands of years, humans have used the constellations for navigation and storytelling. A galactic collision would completely scramble those patterns. Orion's belt would be distorted, the Big Dipper would lose its shape, and entirely new stars would appear in the sky as Andromeda's brightness increases. We would need a whole new set of myths and legends to explain the new sky. It would be a cultural reset for our species. A reminder that the heavens are not as permanent as we like to think. There's also the question of rogue stars. During a merger, many stars are flung out of the galaxies. These stars drift in the dark for eternity. Some of them might have planets. Imagine a civilization on a rogue planet. They would grow up with no night in the traditional sense, or perhaps no stars at all. If their planet was far enough away from any galaxy, their sky would be perfectly black, with only the distant smudge of a few galaxies visible through a telescope. They would have no idea that they were once part of a grand spiral. They would be the ultimate island in a dark ocean. A galactic collision is a factory for these lonely worlds. But what about the starburst knots? These are regions where star formation is so intense that the sky would be filled with brilliant blue light. These regions are also very dangerous. Massive stars end their lives in supernovas, and in a starburst region, supernovas are much more common. If Earth were near one of these regions, our atmosphere could be bombarded by gamma rays and X-rays, which could strip away the ozone layer. This is one of the ways a galactic collision could actually be dangerous. We would want to stay as far away from the nursery as possible. As we move toward the final merger, the new galaxy, Milkomeda, would begin to settle. The dust would be cleared out, either by being used up in star formation or being blown away by the heat of the new supermassive black hole. The result would be a very clean galaxy. Elliptical galaxies don't have the dusty lanes that make the Milky Way so beautiful and hard to see through. Future inhabitants would have an unobstructed view of the rest of the universe. They would be able to see millions of other galaxies with ease. In a way, the collision is the universe's way of cleaning its windows. Some theorists have suggested that galactic collisions might be a way for life to spread. This is the panspermia theory on a galactic scale. If a planet with life is ejected from its home and later captured by another galaxy, or if life-bearing rocks are swapped during a close encounter between two stars, life could travel from one galaxy to another. A collision is a cosmic mixer. It takes life from one corner and moves it to another. It's a very low probability, but over billions of years and with trillions of stars, it becomes an interesting possibility. Maybe we are already the product of such a swap from a previous, smaller collision. Looking at the Andromeda Galaxy today, it is a beautiful, peaceful spiral. It's hard to imagine it as an invader. It's actually very similar to the Milky Way, just slightly larger and with a different history. It has more stars, but we might have more dark matter. It's like two long-lost twins meeting again after billions of years. When they merge, they aren't destroying each other. They are completing each other. The Milky Way provides the gas, Andromeda provides the stars, and together they create something bigger and more stable than either could be on its own. The collision of galaxies is a reminder of our place in the cosmic hierarchy. We are small, our planet is tiny, and our lives are brief. But we have the ability to understand these gargantuan events. We can predict the movements of galaxies 5 billion years into the future. That is the real wonder. Not the collision itself, but the fact that a collection of star stuff on a tiny blue rock has figured out the dance of the giants. We are the observers of the collision, the witness to the cosmic car crash. And even if we don't live to see the final merger, just knowing that it is happening adds a layer of majesty to the night sky. So if two galaxies collided right now, the answer is simple. The universe would get brighter, the sky would get busier, and the future would be rewritten. It wouldn't be the end of everything, but the beginning of something new. It's a transition from a beautiful, fragile spiral into a massive, enduring elliptical. It is a testament to the power of gravity and the endless creativity of the cosmos. The next time you look at the stars, remember that they are all moving, all dancing, and all headed toward a grand finale that we can only imagine. The Milky Way is on a journey, and Andromeda is our destination. We are part of the most incredible show in the universe, and we have the best seats in the house. As the two galaxies become one, the interstellar medium will be flooded with energy. This energy will ripple through the gas and dust, creating vast pillars of creation similar to the ones made famous by the Hubble Space Telescope. These structures are the birthplaces of solar systems. A galactic collision is essentially a giant garden being plowed. The old structures are broken up, and the soil is turned over so that new things can grow. It is a violent process, but a necessary one for the continued vitality of the universe. Without these collisions, the gas in galaxies would eventually sit still and stop forming stars, and the universe would slowly go dark. Collisions are the recharging of the cosmic battery. The fate of Milkomeda is to eventually drift through a much emptier universe. As the expansion of the universe accelerates due to dark energy, other distant galaxies will move further and further away until their light can no longer reach us. Eventually, the only things we will be able to see will be the stars within our own merged galaxy. The sky will become lonelier, but Milkomeda itself will be massive and bright. We are lucky to live in a time when we can still see the rest of the universe and understand our place within it. The collision with Andromeda is the last great local event before the universe becomes too stretched out. So don't fear the collision. Embrace it as the ultimate expression of the universe's dynamic nature. Nothing is meant to stay the same forever. Not the continents on Earth, not the stars in the sky, and not the galaxies in the void. Everything is in flux, Everything is moving, and everything is part of a larger story. The collision of the Milky Way and Andromeda is just a chapter in that story, a beautiful, slow, and inevitable transformation. It is the story of our home, and it is a story that is still being written billions of light years at a time. Stay curious, keep looking at the sky, and remember that even in the middle of a cosmic collision, there is a profound and lasting beauty. Milkomeda is waiting for us, and the journey there is just as incredible as the destination. The collision is not an ending, but an evolution. It's a reminder that even on a scale as massive as a galaxy, there is growth and change. We are small, but we are part of something truly grand. And when you think about it that way, a galactic collision doesn't seem scary at all. It seems like the most natural thing in the world, or rather the most natural thing in the universe. The dance of the galaxies goes on, and we are just lucky enough to be watching. Enjoy the view while it lasts, because even if the transformation is slow, it is the most spectacular event we will ever be a part of. The stars are moving, the galaxies are merging, and the story of Milkomeda is just beginning. What a time to be alive, and what a universe to be a part of. The cosmic car crash is in slow motion, and it is the most beautiful thing you will ever not see. Keep your eyes on the stars, and your mind open to the impossible. The journey is long, but the view is out of this world.